Graphing systems of linear inequalities. Create a graph. Make sure you label your axes and equations. All right. So we have Josie here making baked goods for her Cheer Squad's bake sale. She's selling cookies for $1.50 and brownies for $2.25. She wants to make at least $40 from her baked goods, but only has enough batter to make 10 brownies. Lots of information there. Okay, so we're going to go ahead and identify that X is going to be cookies. Y is going to be brownies. So just like we did with the systems of equations, we have to decide what's going to be my X, what's going to be my Y. Because we don't want to use like weird letters in our equations, then it gets confusing. This also helps with then labeling our X and Y axis. Since X is cookies, the title of my X axis is going to be cookies. And she's selling them, so this is going to be cookies sold. And because I decided that Y was brownies, the title of my Y axis is going to be brownies sold. We're not going to label those increments yet because we're not 100% sure what we need them to be, right? So, inequalities. How many brownies can she make?
10.
10. So Y has to be less than or equal to 10. That's why it's Y is less than or equal to 10. She can only make 10 brownies. She doesn't have enough batter to expand her brownie empire. How much does she make per cookie? How much does she make per brownie? $2.25. She wants to make at least $40. So what inequality sign would I use for at least $40? Kaden?
Greater than or equal to?
Yep. All right. This one is not in slope-intercept form, so we have to rearrange it. Take away the $1.50x. Divide by 225. We end up with Y is greater than or equal to, this is going to be negative 2/3 because 75 cents can go into $1.50 2 times and it can go into 225 3 times. If you actually did the math, you'd get like 0.6 repeating, which you all would know is 2/3, right? And then this turns into a really awkward, like 17.8. Kind of weird, but that's okay. We can still work with it. So I've got this inequality to graph, and I've got this inequality to graph. So let's look at our y-intercepts. We know we need our y-intercepts to go up to at least 17.8. So what do you think would be a good increment to go by for our y-axis? That's going to make it really small down here. But we have more space, so maybe not 4. What might be another one? 2, right? So if we go by 2's, you have plenty of space for our y axis and our y-intercept. How about for our x-axis? What do you think we should go by for our x-axis? Go by 2's again? Let's look at our slope. Our slope is -2/3. So that could help us to make it a little bit easier. These are going by 2's. What might make it easy if we do 3's? Oh, you guys are on it. So you have to create the inequalities, then you have to decide how you want to graph it. So I'm going to do y is less than or equal to 10. That's easy. That's going to be a horizontal line. And it's going to be a solid line because it's or equal to. And all of those values are down here this way because it's less than or equal to. Remember, she's not going to be selling more than 10 brownies. And then for the other line, we've got 17.8. So I'm going to put that right about here. And I'm going to go down 2 over 3. So down 2 would be down to 15.8. And then over 3. Down to 13.8 over 3. Down to 11.8 over 3. Does everybody see what I'm doing there? I'm paying attention to the increments. 9.8 over 3. 7.8 over 3. Oops. This is also going to be a solid line. Which way am I going to shade for this one? This time it's greater than or equal. Above or below? Above. All right. How many cookies or brownies could she sell? So let's come up with two possible solutions. So we'll give the ordered pair and then what that ordered pair means. Jackson.
24, 10.
Sure, 2410. And what does that represent?
24 cookies.
Sure. Awesome. So in this situation, it would be crazy if all of us or any of us had the same ordered pairs because you could pick any combination in here. So, Landon, give me another one.
27, 8.
27, 8, yep. And that represents 27 cookies and 8 brownies. Does anybody have questions about how we did that? All right, let's go on to the next page. Actually, I want to skip this one for right now. I want to go on to the next one because for this one, you need 3 colors. What? So pick out another color. Doesn't matter which one you use. I think I'm going to use orange, but you can use whatever you want. Okay, read this scenario about Ariel to yourself, and then we'll chat about it. Huh? She's just the girl that got a job at the restaurant. We're moving to number 3. You saw that, right? Yeah, just a girl. I don't think she's a little mermaid, but maybe. Maybe she was told to get a job. I don't know. What are my variables going to be? What are the 2 things that we're looking at here today? Addison Bowles.
X for sure.
Yep. Which means Y is going to be pants. Because when you get a job, sometimes they require you to dress a certain way. Right? So that tells me that my x-axis is going to be shirts. And my y-axis is going to be pants. So she found shirts that she likes for $7.50 and pants she likes for $18. She needs at least 2 shirts and at least 2 pairs of pants and wants to spend no more than $150. Whew! All right. So if she needs at least 2 shirts, we know that one of our inequalities has to be x is greater than or equal to 2. If she needs at least 2 pairs of pants, y is greater than or equal to 2. And then we have to figure that into how much she can spend. So who wants to tell me what you think the third inequality will be? Hayden.
Something like 7.5y plus, wait, hold on. The shirts are, so 7.5x and then 18y, and that has to equal to the 150. Well, greater than or less than or equal to 150.
Less than or equal to, because she can't spend more than 150. We'll pretend tax is like all in there. Don't get caught up in the tax situation. So perfect. 7.50x plus 18y has to be less than or equal to 150. That's all she's got to spend. So I'm going to subtract the $7.50 x from both sides. 18y is less than or equal to negative 7.50x plus 150. So this seems weird because you have like 750 and 18. That's a weird fraction, right? How does this work out? So if you were to simplify these by dividing these both by $1.50 right here, because $1.50 can go into 750 and $1.50 can go into 18, y is less than or equal to negative 5/12 x. And then you get this weird 8.3 because 150 divided by 18 is 8.3. So if you just did that in your calculator, that's what you would get is 8.3. So now we need to decide what we want our increments to be down here. We have 8.3, which isn't too terribly, we could go by ones, but look at my slope. I have to be able to go over at least 12. Am I going to be able to go over at least 12 if I stick with single digit increments? Nope. So I'm going to go by twos. All right, so we know that she needs at least 2 pairs of pants and at least 2 shirts. So pretty easy peasy. For the pants, since that's x is greater than or equal to 2, that means all of my x values are 2. So that's a vertical line. I'm going to make that one the yellow. And everything greater is going this way, right? A lot of yellow. My y is going to be a horizontal line. That means all of my y values are greater than or equal to 2. So that's going to be everything above that line. But because she doesn't have an unlimited budget, that's why we need that third inequality to figure out how many can she actually purchase. So right now it looks like she can pretty much purchase as many as she wants. But we're going to add that restriction here in a second. So then our last inequality is going to be orange, or whatever color you chose. I'm going to plot my y-intercept, which is 8.3. And I'm going to go down 5. So I'm going to be at about 3.3, and I'm going to go over 12. Can't plot anymore. Notice that I didn't go over 12 lines. I went over 12 shirts. Went down 5 shirts, not 5 lines. And I'm just going to connect these. And this again will be a solid line. And that's actually less than, so it has to go lower than the line. And so then once you figure out which section is supposed to be triple colored, you can kind of go back over some of them to make it look more obvious. Got this kind of ugly color here. Okay, we're going to stop there because I feel like you guys could easily come up with 2 solutions. Before you move, wait, freeze and listen. Freeze and listen. If you don't have colored pencils at home, please feel free to take some home with you today if you need them for while you're at home. I'm also, what? I'm not done. Please sit down. You are going to be staying late because you can't follow directions. Everybody's going to have to sit. Thank you. I'm coming around with your study guide. Nope, don't leave. You're going to put this in your binder. The binder goes with you. You go straight to your locker and put it in your backpack. Everybody understand? You have today's papers, and then you have this study guide. I haven't decided yet. Maybe I'll see you tomorrow. I don't know. No offense, but yeah, it'd be great if I wasn't here. I mean, I'll miss you, PK. Okay, keep the colored pencils if you need them.